In this lesson, the first thing we're going to look at is our land survey and our offset survey. So when surveyors measure on a regular block, we try and break it up into triangles, trapeziums, rectangles, because it makes it easy to be able to find the full area of that block. So you may see surveyors out and they're setting up and trying to find those distances. So what you can see here is an irregular block of land. All the measurements are in metres and we need to calculate the area. So what I've done here is firstly labelled all of our points or our edges of our irregular shape. So the first thing we always do is we go up and down the middle with A and B. It doesn't matter if you go top to bottom or bottom to top. And then work your way around and label through the alphabet. So every little meeting of lines has a letter attached to it. I then go through and I find the area of each of the 5 shapes here. Or what you could do is say you've got 1, 2, 3 different shapes on the right hand side and one large triangle here on the left. So I'm going to start first with finding the area of A, B, E. So my big triangle here on the left. Okay, we know it's a triangle. We looked at area last lesson, so a half BH, half times the base. So my base here, if I'm working my way up, I have 5 plus 17 plus 7 plus 5, which gives us 34. And the height of my triangle here is 20. That gives us 340 metres squared. So I've found the area of that left-hand triangle. Now I'm going to find the area of this bottom triangle here. So AFC, again we write our formula. So the base of my triangle is 5 and the height is 23. And working that out we get 57.5 metres squared. Then I'm going to find the area of this top triangle. So area of BHD. So we get the half times the base, which is 5. You can have the base as 14. Okay, it doesn't matter, they are interchangeable. And that gives us our area of 35 metres squared. And then my last shape here on the right, okay, this is going to be a trapezium. So we can just say area of DHFC, and we know our formula for the area of a trapezium is our trickier one there. So a half times A and B are the 2 parallel sides, so 14 and 23. And the height, I just need to add these 2 here together. So that's going to give us 24. And working that out gives us 444 metres squared. The last thing I need to do then is add all of our areas together to find the total area. So if we add them all together, we end up with 876.5 metres squared. And that's what surveyors will do if it's not a regular, triangular, rectangular, square block. Now from here, what we need to do is we need to write what we call a notebook entry. So to do a notebook entry, it's basically working out, well, if you didn't have a diagram, how could you draw a diagram with just the measurements given? So we start with like a parallel lines in the middle, and we label these with A and B, so up through the middle. If I start at A, I'm at 0. To move up to my next point, which is F, I've moved up 5, and from that 5, I then move out 23. So, and it's to the right, so I go 23, and that gives me point C. Then from 5, I'm moving up 17, so I need to add that together. So 5 and 17 gives me 22. So up the middle becomes a running measurement. Okay, I'm not just saying, okay, well then 17 more. It's adding it on as I go. Once I've moved up that next 17, so I'm up 22 in total, I move 20 out to the left, and that is to point E. Coming back to the centre here, I'm moving up another 7. So I need to add 7 to 22, which gives 29. And at that point, I go 14 out to the right to point D. The last thing I then do is move 5 more up. So I need to add 5 more to 29, which is 34. So that's what we call a notebook entry, moving from the bottom to the top, showing all the different lines that move out. The second thing we're going to look at in here is called the trapezoidal rule. Now this is a little bit complex. So a trapezoidal rule is for measuring the approximation of an irregular shape, okay? The rule is the area is approximately h over 2, the distance of the first plus the distance of the last. So h is the distance between the two measurements, df is the first, and dl is the last measurement. So you can see that little diagram there. So if we come down and look at this example, I'm just going to put some little markings on here. So we're going to say this point here at the end is our df for our first, and then this is obviously going to be our dl for the last measurement. So if I'm using just one application of the trapezoidal rule, so area is approximately h over 2 df plus dl. So the height is what is the measurement between these two. And if we look at the scale down here, I have that. So you can say that df is 0, where I start at 0. dl is where I'm ending, and it's the height of that there, so that's 18. And then I've got which is the scale, being 10. I then put all of that information into here. So df is 0, and dl is 18. So I'm finding, so this becomes 5, so it's 5 times 18, which is approximately 90 meters squared. So that's if I use one application, so just using it once, working it through. If I use two applications, I'm going to divide this into the two sections that are there. So if we say this is df, this is dl, and then if I did the second application, this is df, and this is dl. So you can see it's broken up there. So if I look at the first area, I have the h2. I'm not going to write this formula again, so I might run out of space, but we would write our formula if that's what it asked. So the distance between these two, so our h value is going to be 5. My df is 0. My dl is 15. Okay, looking here. So h is 5, so 5 over 2 times df is 0 plus dl, which is 15. So I'm getting here 37.5 meters squared. And then if I'm, they are approximations, not equals. If I look at area 2, again, it's a 5 meter for my height, so my height is 5. My df this time is where I'm starting here, so that's 15. And my dl is where I'm ending here at 18. So I have 5 over 2 times 15 plus 18. And that gives us 82.5 meters squared. From there I need to do the total area. So it's my A1 plus my A2. So I get 37.5 plus 82.5, which is 120 meters squared. So we can see there is a little bit of a difference here between those measurements. So for part C, it says which answer is more accurate. So we can say here that our 120 meters squared is more accurate. And that's because the more times that we do the application, so the more times you do the application, so the smaller the pieces are, the closer we get to being accurate. Okay, so using that trapezoidal rule, you might be asked to do one application, two, but if you do more and more and more and more and more, so break it up by drawing closer together parts there, you will get it more and more accurate to that exact area.